So these compounds are combinations of atoms of different elements in specific ratios, and we use chemical formulas to indicate the elements that are present in the compound and the relative numbers. So we do this using the element symbols and numerical subscripts. Sub, like submarine, goes below. So a subscript is a lowered number. So water is represented as H2O. This 2 refers to the element before it. So this formula tells us there are 2 hydrogen atoms and 1 oxygen atom in a molecule. Carbon tetrachloride has the formula CCl4. So 1 carbon atom and 4 chlorine atoms. You have to be a little bit careful. Is that a capital I, a lowercase l, or the number 1? Whatever you say it is, I could say it's the other. When I write, as opposed to typing, I try to be very clear. So that's my capital I. This is the number 1. And I make my lowercase l's as a script L when I'm writing formulas. Because even with typing, some fonts are not super clear. And this L here, like, is that an I? Is that carbon, and 4 iodines? You have to use a little bit of common sense, because why would we put carbon? We'd put C2 instead. So this is Cl. Handwriting that, I would write it like this. Oops. Good grief. So that it's more clear. There are 3 different types of chemical formulas: empirical, molecular, and structural. Empirical is a word that means from experiment. So anytime you see empirical, this has to do with something that we got from experiment. A formula derived from experiment just gives us the relative numbers. It doesn't actually give us the number of atoms in a molecule. And we'll see an example in a minute. A molecular formula, which is what we probably think of as a regular formula, gives the actual number of atoms of each element in a discrete molecule. So as an example, for this compound C4H8, that's the molecular formula. In one molecule, there are 4 carbon atoms and 8 hydrogen atoms. But that's not the lowest ratio. If we determined the formula experimentally, we would come up with CH2. Because for every 1 carbon atom, there are 2 hydrogen atoms. So essentially, an empirical formula is like a reduced fraction. Right? If we had a fraction 4 to 8 in elementary school, your teacher would want you to reduce that and call it 1/2. Because both the numerator and the denominator are divisible by 4. Another example, B2H6, that's the molecular formula, but the lowest ratio is BH3. Sometimes the molecular formula and the empirical formula are the same. In carbon tetrachloride, CCl4, this is the lowest ratio. So they can be the same, but they don't have to be. The structural formula helps us to understand how the atoms are connected. So hydrogen peroxide is H2O2. The structural formula would be H-O-O-H. This shows us that these atoms are connected in a line. Because it might not be immediately obvious, well, why not like this? Or There's all kinds of different combinations. Some of these don't exist, by the way. Those don't even exist. But there are, especially in the organic compounds, two compounds can have the same molecular formula but different structural formulas because the atoms can be put together differently. So the structural formula tells us how the atoms are connected. It also indicates whether there are single, double, or triple bonds.
Okay. So is the structural formula the same thing as like the condensed formula?
Is the structural formula the same as a condensed formula? A condensed formula is actually a condensed structural formula. So condensed and expanded and line angle formulas from organic chemistry are all forms of structural formulas. They show connectivity.
Okay. And would this not be a structural formula if like the bonds weren't connected? Or would it just be...
This is not a structural formula. You could possibly say HOOH. You might describe this as a structural formula because it indicates connectivity, but it doesn't specify whether those are double or triple bonds or what they are. One of these formulas is not better than another. They are all convenient in certain situations. The structural formula is going to give us the most information. It's also the longest, the most tedious to write out, and on a computer basically often requires you to use some sort of a graphic or a drawing program. So we don't use structural formulas a lot, only when we're interested in how it connects. We use molecular formulas the most. Empirical formulas give the least information. We also make use of models in chemistry. A model is just a representation of what the molecule looks like. So ball and stick model uses balls and sticks. We typically have specific colors for the different elements, but that's not universal. So here's molecular structural, an example of a ball and stick model. This is going to show more information than the structural because this is three-dimensional. And this is a space-filling model. Those are really hard to draw, but it's actually the best visualization of what a molecule actually looks like. They don't really look like this. So this shows a few different compounds and different ways of representing them. And so we need to understand what each of these different formulas and models represents because we end up using all of these at one time or another.